So here are the notes for 6A.4, compound probability. So today you guys will be finding compound probabilities as well as the complement of an event. So let's talk about this. I'm going to go ahead and do the shade so you guys can kind of talk about these. So let's talk about our first definition, a compound event. That basically is the union or intersection of two events. So here, make sure you're writing these down while I'm also explaining. Union means or. So like you have this or this. While intersection is representing and. Now we have these two Venn diagrams over here. Let's have our first Venn diagram represent our or. Now when we do or, remember we had that union symbol? Well, that's what it represents, our or. And when we talk about or, basically that means that everything has something in common, meaning that we have A and B have something in common. That's basically what a compound event, events that have something in common. But our and intersection, that symbol goes downwards, so it's like an upside down U. And basically what and represents is what A and B both have in common. So it's just the middle part of our Venn diagram. So notice the difference between or and and. Or is everything from the Venn diagram, while and is just the intersection of the Venn diagram. Okay, let's talk about overlapping events. Events that have one or more outcomes in common. Basically, your overlapping events is the inside or the middle part of the Venn diagram. And then lastly, disjoint / mutually exclusive. Now these are events that have no outcomes in common. Now notice here that A and B, they are not intersecting each other. They are distant, so that means they don't have anything in common. So make sure you get these vocabulary words down. If you need to pause the video, make sure you do that so you can get all of this down. Okay, now let's talk about our little formulas for this. So probability of a compound event. If you have an or event, so the probability of A or B, and we're doing compound, to figure that out is we do probability of A plus the probability of B, and now we subtract it from the probability of A and B. What we're basically doing with this right here is subtracting the double count, because we don't want to include that middle part between where A and B intersect, okay? Now you will also need to write this down since I don't have it. We also have to talk about compound events when we have A and B. So when we have the probability of A and B, this is how we will calculate it. We have the probability of A plus the probability of B. And kind of in a similar fashion, we're going to subtract it, but in this case from the probability of A or B. Once again, what you're trying to do is subtract the double count. So we're trying to get rid of this little section and this little section of the Venn diagram, and really just making sure we get the in-between or the intersection of A and B. Now let's talk about disjoint or mutually exclusive. Remember, this is when no outcomes have in common. Now, if we have a probability of A or B, it's okay that they don't have anything in common, because we can just calculate the probability of A and then add it to the probability of B, like we've been kind of doing with any or type of problems. However, if we have the probability of A and B, since there's no intersection part, really that probability is 0, because it can't happen at all. So make sure you remember that the probability of A and B when it's mutually exclusive is always 0. Okay, let's go ahead. Let's use this information now to calculate our following examples. So let's look at number 1. It says a card is randomly selected from a standard deck of 52 cards. What is the probability that it is a 10 or a face card? Now with these problems, you will have to kind of ask yourself, do they have something in common? Basically, are they compound events? If not, then they might have to be disjoint events. So let's think about this. We have a 10 and a face card. We have to think, can a 10 also be a face card and vice versa? Well, no, they can't. A 10 is a different type of card than any of the face cards. So in this case, this is not a compound event, but a disjoint event. And since this is an OR type of problem, all we have to do is calculate the probability of A plus the probability of B, and then that'll be our answer. So we're going to do the probability that the card we pick is a 10 or a face card. And I'm going to do F to represent face card. So now our next thing is to count, well, how many 10s are in a standard deck of 52. Now this might be where you need to get your pink sheet out and then look at your cards, or you still don't remember all the cards, okay? So know that there are 4 10s in a standard deck, okay? Because you have the 4 different types of suits. So that means we have 4 out of 52. Now, because this is OR, an mutually exclusive or disjoint event, we add it with the probability that the card's going to be a face card. Well, remember, if you count, face cards are the kings, queens, and jacks. Basically anything with a face. So that means there are 12 of these in our 52 card deck. So we do 12 out of 52. And then because we have the same denominator, we add the numerator, so we get basically 16 over 52. But remember, anytime you get a fraction, make sure you simplify it all the way. So let's simplify this. So we should get, because we know 4 can go into 16 and 52, 4 out of 13. Or you can also write your final answer as a decimal. So if you plug 4 out of 13 in there, then you should get this. And we're going to go ahead and round for all our notes probably today, unless it terminates, probably to 4 decimal places. So it should be about 0.3077. So you can either write it as a fraction or a decimal, but if you do write it as a fraction, make sure you simplify or just do 16 divided by 52 to get your decimal. Okay, let's go ahead and try number 2. So it's going to be something similar. So it says a card is randomly selected, once again, from a standard deck of 52 cards. What is the probability that it is a face card or a spade? So once again, we got an OR problem. So we need to decide, is this a compound event or a disjoint event? Well, let's think about this. Can a face card be a spade? Well, yeah, if you look at your 52 cards, remember, face cards are the king, queens, and jacks. So that means we can have a king of spades, a queen of spades, and a jack of spades. So that means this is a joint event or a compound event because face cards and spades have something in common. So now what we need to do is use our formula from up here to find our answer for number 2. So we're going to do the probability that the card we pick is a face card. Once again, I'm going to use F for face card, or a spade. So S for spade. Now when we do this, we need to find the probability of a face card. Well, we already calculated that. That was 12 over 52. And then we add it to the probability that we have a spade. Well, if you need to, make sure you count your spades. There's actually 13 of those. So we have 13 over 52. But now what we need to do, because this is a compound event, is subtract it from the probability of A and B. In this case, the probability that we have a face card and a spade. So we subtract. So now we got to think about, well, how many face cards are spades? Well, that means we have the king of spades, the queens of spades, and the jack of spades. Well, that means we have 3 of them that are face cards and spades. So we subtract from 3 over 52. And then from there, we go ahead and we add or subtract our numerator. I guess we're doing both. So we do 12 plus 13 minus 3, which that's going to give us 22 over 52. And remember, you can leave your answer as a fraction, but make sure it's simplified. So if you left this, we want to simplify 22 over 52 to give us 11 over 26. Or you can write it as a decimal. And if you did, it would be approximately 0.4231. So that would be our probability there. So remember, because we are doing probability, we want our favorable outcome over the total amount. Okay. Okay, let's go ahead and try one more. So we're going to do 3 together. Scroll this down. There we go. So number 3 says, in a poll of high school juniors, 6 out of 15 took French, 11 out of 15 took math, and then 14 out of 15 took French or math. We need to find the probability that the student took both French and math. So this is an and. So now we got to think, is this a disjoint event or a compound event? Well, they give us the total that took French, total that took math, but they also tell us the total that took French or math. Because they gave that information to us, this is a compound event. So we are going to find the probability that someone took, or a student took, French and math. So I'm going to just do F for French and then M for math. Very simple there. So in order to calculate this intersection, we need to find first the probability of just French. Well, they tell us in this little sentence here that 6 out of 15 took it. So we're going to do 6 out of 15. Then we're going to add it to the probability of those that took math. Well, they said here 11 out of 15 took math. So we do plus 11 out of 15. Now we need to subtract it from the probability that someone took French or math. We're trying to get rid of that overlap there, or the double. Here it says that 14 out of 15 took French or math. So we're going to subtract it from 14 out of 15. So once we've done that, we're going to go ahead and calculate. So we have 6 plus 11 and then minus a 14. That's going to give us 3 out of 15. And remember, don't forget, if you do leave your answer as a fraction, simplify it. So this gives us 1 out of 5. Or you can leave it as a decimal. Now in this case, we're not going to round to 4 decimal places because it does terminate at just 1. So it's fine just to leave your answer as 0.2. And that'll be your answer. Okay, so there is a 4, and what I would like you guys to do, because number 4, A, B, and C, they're very similar to 1, 2, and 3, what we just done. I would like you guys to go ahead and pause this video and go ahead and try A, B, and C on your own. Once you're done, then go ahead and play the video. Or if you get stuck, you can start playing it and then pause it again, so if that helps you a little bit, and then keep going on. Okay, so hopefully you paused the video, you tried A, B, and C, and let's see if you got them correct. Okay, so it says for number 4, in a survey of 200 pet owners, 103 owned dogs, 88 owned cats, 25 owned birds, and then 18 owned reptiles. So notice here that 200 is going to be our total, and then each individual amounts. So on part A, it says none owned both a cat and a bird. What's the probability that they owned a cat or a bird? Okay. Now, because they tell us that none owned both a cat and bird, this is actually not a compound event. This is just our disjoint. We're really just trying to find what's the probability that someone owned a cat or owned a bird. So what we're going to do is just add the two probabilities and get our final answer. So this is going to be the probability of a cat or a bird. So remember cats, let's go back up to our sentence, what they told us. They said 88. And remember, they surveyed 200 people. That's our totals. We have 88 over 200. Then plus, because remember, this is just an ordinary OR type of problem, so we always add for those. Then we want to think about birds. So they said that for birds, 25 own them. And remember, they surveyed out of 200 people, so that's our total amount. So now we just basically add up. It should give us 113, I believe, out of 200. Or you can also write this as a decimal. Oops, that's an equal sign. So it should give you approximately, say, 0.565. And then I'm going to go ahead and make sure we have it to 4 decimal places because I want to keep it the same, kind of just throughout the notes. Well, it terminates, so that's why we don't have anything more. So remember, if it just terminates, then you don't need to round to 4. So that'll be our final answer there. Okay, let's go on to part B. So if you just tried A, you wanted to see your answer, that was fine. If now you're trying to start part B, pause this video right now and try it on your own. Okay, let's go ahead. We're going to go over part B. So it says 52 owned both a cat and a dog. What is the probability they owned a cat or a dog? So once again, here's our or, but they also tell us how many own both a cat and a dog. So that seems because we are given that information, this is going to be a compound event. So they give you something that is the opposite. Go ahead, that's probably going to be your compound event. So we're going to do the probability of a cat or a dog. And in order to do this, we need to do the probability of a cat, which we kind of already found beforehand. That was 88 over 200. Then we added to the probability if someone owned a dog. So we do need to go back up. It says 103 owned a dog. And now we want to subtract the double because we don't want everything. So now we're going to put over the probability that someone owned a cat and a dog, which they told us in this case is 52. And it's still over the same amount of those that were surveyed. So that's going to be 200. Okay, so once again, we are going to add and subtract because there's both here. So we add and subtract the numerators. So we're going to get 139 when we do that. And remember, the denominator just stays the same. Please do not add that. So this cannot be simplified anymore, or you can also just put it as a decimal, which we get about 0.695. And that will be your answer there. Okay, let's go ahead. Let's try our last one. I might have to keep scrolling up and down so I know. So C, once again, same thing as B. If you've tried A and B, but you want to pause the video now to try C if you haven't already done so, go ahead. Okay, let's go ahead and go over this. So now in C it says 119 owned a dog or a reptile. What is the probability they owned a dog and a reptile? So this is basically just the reverse of part B. So they give us the or, we're trying to find the and, meaning this is going to be a compound event. So we're going to have to do the probability that someone owned a dog and a reptile. I know that looks like a P, but that's actually a D to represent dog. There we go, and R for reptile. So dogs, I think it was 103, so we have 103 out of 200. And we added to the probability that someone owns just a reptile. And here said that 18 owned a reptile. Now we need to subtract it from the probability that someone owned a dog or a reptile. In this sentence, they told us that 119 owned a dog or reptile. So we're going to do minus 119 over 200. So now what we're going to do is add and subtract our numerators. So when we do that, we get about 2 out of 200. And then don't forget, if you are going to leave your answer in fraction form, make sure you simplify it. So this is 1 over 100. Or you can write your answer basically in decimal form. So this would be 0.01. Okay, let's go ahead and we're going to go to our next part of the notes, which is going to be the complement of an event. So complement event is just basically what we call A prime. It is all outcomes not in A. Sometimes we use this just to make it a little bit easier for us to calculate instead of maybe counting because it's a really high number. So we do 1 minus not the event. It's a little bit easier to do so. So let's talk about the formula. So the formula, so this is saying probability of A prime. So this is a prime sign if you did not know that. Is equal to 1 minus probability of A. What this means is the probability of not A is equal to 1 minus the probability of A occurring. Okay, now let's go ahead. We're going to use this to do our 5A and B. I'm going to just scroll down just a little bit. There we go. Can still see our formula because that is important. So it says a card is randomly selected from a standard deck. Now remember, anytime it talks about a standard deck, that's always 52 cards. Okay. If anything else, you can always just count all the 52 cards. Part A is what is the probability that the card is not a king? So make sure you really pay attention to the wording. Sometimes it's going to ask what's the probability that it is something or is not. So that's where you really need to read carefully these problems. So what we're going to do is find the probability that the card is not a king. So remember, to represent not, I'm going to do K prime. That means not, in this case, a king. Now to find that, we are going to do 1 minus the probability that the card is a king. So that means we're going to have 1 minus. Now, probability that the card is a king, all you have to do is count all the kings in a standard deck, which there should be 4 of them. So we have 4 kings out of, remember, there's 52 cards in a standard deck. That's our total. And then once again, you can either leave your answer as a fraction or a decimal. If you're going to do it as a fraction, make sure you simplify. So we do 1 minus 4 over 52. Remember, really you're just subtracting 4 from 52 cards, so that should give you 48 out of the total 52. So 48 are not kings. Now, we're going to go ahead and simplify that. So that's going to give us 12 out of 13. That's our probability. And if you wrote that as a decimal, it should be around 0.9231, which that sounds about right because about 92% of the cards should not be kings. Okay, let's look at 5B. Now, actually, what I would like you to do is go ahead and pause the video and try to set up and solve part B. This is once again just using the complement because notice it says not an ace or jack. Okay, so go ahead, pause the video, go try to set this up and try to solve this problem. Okay, hopefully you paused the video. If you got stuck, let's see what we can do to get you unstuck here. Okay, so it says, what is the probability that the card is not an ace or jack? So this is using our complement. And remember, in this case, it says or as well. So this is an or type of problem. Now we do need to think, is this a compound event or is this a disjoint event, meaning they don't have anything in common? Well, can an ace be a jack and vice versa? Well, in this case, no. Aces are a totally different type of cards than jacks. So because they don't have anything in common, this is a disjoint event. So all we're going to do is just add our probabilities here of an ace and a jack. and then subtract it from 1 because we're trying to find the probability that the card is not an ace or jack. So that means the probability of A prime or J prime. So not an ace or not a jack. But to do this, what we're going to do is do 1 minus the probability that the card is a ace or a jack. Okay, so now we have 1 minus. So first we find the probability of an ace. Well, just like all other those type of cards, we have 4 of those in our standard deck. So 4 out of 52. And we added to the amount of jacks. Once again, we have 4 of those. So we have 4 out of 52. So now we subtract. Really, you have 8 total, okay? And you're subtracting from 52 of the cards. So that's going to give us 44. So 44 out of 52 are not aces or jacks. Or another way of saying this, because if you are going to leave your answer as a fraction, make sure you simplify. So 11 out of 13. Or you can also put it as a decimal. So about 0.8462. That would be the probability that the card you pick is not an ace or a jack. Which that kind of sounds right, because about 84% or a little bit, 85% if you want to round there, of the cards are not aces or jacks. Okay, let's go ahead and do our final 2 problems. Now, once again, these are using the complement. So we're still going to do 1 minus not. So we have number 6 is a restaurant gives a free fortune cookie to every guest. The restaurant claims there are 500 different messages hidden in the fortune cookies. What is the probability that a group of 5 people receive at least 2 fortune cookies with the same message inside? Okay, so this is why sometimes we might want to use the complement instead of trying to find. Because here, notice what it says. It says at least 2. So if we were trying to find this, we would have to find the probability that at least 2 of the fortune cookies have the same message, at least 2 or 3 of the fortune cookies have the same message, 4 of them have the same message, or 5. So that would be 2, 3, 4, 5. That would be 4 different probabilities we would have to find, which that can get very tricky. Or we can just use the complement to make it a little bit easier on ourselves. So we're going to find the probability that at least 2 have the same message. Now, I only went up to 5 because in this case, it said only 5 people receive the fortune cookies. Otherwise, I would have kept going on to how many people there were total. So I'm going to say same message. That means if we're going to do the complement, we're going to have 1 minus the probability. Now, some of you might say that only 1 have the same message. But does that really make sense? Because you need to have 2 fortune cookies to actually have the same message. 1 is not going to have it. So in this case, the complement of at least 2 having the same message is actually going to be none. So none of them have the same message. So I'll just put none, same message to make it, don't have to write as much. So kind of be careful when you're doing the complement. You have to really think what makes sense. So none of them have the same message makes sense. Okay. So let's talk about how to find the probability that none of the fortune cookies have the same message. So this is actually where our counting principle is going to come into hand. So we're going back to some of that old information. So I'm going to kind of scroll down so I have more room to do this. Now remember, there are, when we do our fraction or probability, we have the number of favorable outcomes over the total. So our favorable outcomes is saying none of the fortune cookies have the same message. So remember, we have 5 people total, right? So we have 1, 2, 3, 4, 5. If the first person just picked out of all 500 messages, well, how many choices does that person have? In this case, 500. They have all the choices they can pick. Now, if we go to the second person, remember that second person can't have the same message as the first. So that person only has 499 options left. Remember, when we do our counting principle, we are multiplying everything in between. Okay, so now the third person, that person can't have the same message as the second or the first, meaning that person can only choose from 498 options or messages. Okay, the fourth person, and hopefully you can see the pattern here, they can't have the same message as the third, the second, and the first person, meaning they only have 497 options left. And then the fifth person only has 496 options left because they also can't have the same message as the fourth, third, second, and first person. So it looks like to figure out, to calculate that none are the same or none have the same message, we're going to go ahead and do 500 times 499 times 498 times 497 and then times 496. Now we need to put this all over the total amount, so all the options. So if we think about it, once again, we have 5 people, okay? But if we're thinking about the total amount, this also includes those that all of them get the same message or none of them get the same message. So to include all of those options, well, we think about the first person, they can choose from 500, right? Well, the second person, they can also choose from 500 because they could have the same message or they might not have the same message. We're just trying to find the total amount of outcomes. Well, the third person, they can choose from all 500. The fourth and the fifth can also choose from 500. So that means our total amount is we have 500 and really to the 5th power because there's 5 of those people. Now from here we kind of calculate, it might be better to get your answer as a decimal than a fraction here. So we're going to do 1 minus. Now, in this case, we're going to plug this into our calculator. Make sure the top portion you use parentheses, okay? So in our calculator, we have parentheses 500 times 499 times 498 times 497, and then times 496, and then divide that all by 500 to the 5th power. And then once again, since we're kind of keeping the same, let's round to 4 decimal places. So we get about 0.9801. So that's going to be 0.9801. And then we subtract that, so we should get about the probability 0.011 or 199. So that is the probability that at least 2 of the fortune cookies will have the same message inside. That's not a very high probability. Okay, let's get to number 7. Now number 7 is going to be very similar to number 6. And this is what I would like you guys to go ahead and do. I would like you to go ahead and pause the video, relook at number 6, relook at how we did that in the formatting of it, because the formatting is going to be very similar to number 7. Go ahead and set up number 7 and find your answer. Okay, hopefully you paused the video, you tried to do this on your own. If you got stuck, let's see where you got stuck and where you went wrong there, okay? So number 7 says there's 3 prizes that are being drawn at a raffle. 157 tickets are sold. Now after each prize is called, the winning ticket is returned to the box and is eligible to be picked for another prize. What is the probability that at least one of the tickets is drawn twice? So this is what we're trying to do. So once again, we're going to do the complement, because if we actually had to find at least 1, 2, 3 tickets or anything like that were drawn twice or more, that would be very long and very hard. So let's kind of do the complement, all right? So the probability that at least one ticket drawn twice. So our complement, we're going to have 1 minus. Now remember, at least 1, if we go the opposite, really all we have is, well, what if none of the tickets are drawn twice? What if each ticket was just drawn basically once? So a prize was given to 3 different people. So we're going to find the probability that no tickets were drawn twice. There we go. Ooh, it takes me so long to write that. Okay, so to do this, once again, we're going to use the counting principle to help us out. Now, there are 3 prizes, right? So you got 1, 2, 3. Each prize has a winner, okay? So get a raffle ticket, you win the prize. Now, if we're doing the complement that none are drawn twice, that means when we draw for each of the prizes, the same ticket's not drawn again. So for the first prize, well, we have a total of 157 tickets. Remember that all of that information is in this little paragraph, okay? But if these tickets cannot be drawn twice, meaning they can only be really drawn once and that's it, if the second prize, we can't reuse that raffle ticket. So now there's really only 156 options left for the raffles. And then for the third prize, well, the first 2 tickets, they can't be drawn again. So that means we really only have 155 raffle tickets left. So this is going to be in the numerator of our probability. So we're going to have 157 times 156 and 155. But when we do our denominator, remember that's the total amount. So that means that all the tickets can be drawn twice, or 1, or 2, or none. So we want all the options. So we think about all the options. Remember, there's 3 prizes. For the first prize, once again, you have 157. For the second one, well, we can count the 1 ticket again, or we don't have to. So we still really have 157 options. And for the third, that could be the same thing. So these 2 could be the same ticket if they want to. So we still, once again, have 157 options. So to rewrite that, we're going to have 157 to the 3rd power. And just like we did before, we're going to plug in our 157 times 156 times 155 all over 157 to the 3rd into the calculator, because we'd probably rather get a decimal than a fraction for that. Don't forget that in the numerator, you do need to have parentheses around it. And it looks like we get 0.98. We'll just round up a little bit there, 10. So we have 0.9810. And then when we subtract that, the probability that at least 1 ticket drawn, or 1 ticket being drawn twice, is going to be 0.0190, which once again is going to be a low probability. That's just because you have so many options. Okay, So if you have any questions over the complement or disjoint events or compound events, make sure you email me or come in before after school, or if I'm not available, make sure you go to another teacher to get help. You can also look, I'll have the filled in notes on Schoology, so you can use that as well. Basically everything we did in the notes will be on the homework. And just once again, make sure if you have any questions, email, come in before after school, or go to another math teacher to get that help.